In this video, I'm going to talk to you about three vector quantities: displacement, velocity, and acceleration. Recall from Unit Not that a vector is a quantity that has both magnitude and direction. And again, the three that I'm going to focus on in this video are displacement, velocity, and acceleration. Now, horizontal and vertical displacement are denoted with different variables. Horizontal displacement is denoted with an X, whereas vertical displacement is denoted with a Y. Also notice, by convention, an arrow is placed over the variable to denote that these are vector quantities and have both magnitude and direction. We'll use a V for velocity and an A for acceleration. Also recall that there are several ways to describe the direction of a vector quantity. We can use signage, such as a plus or minus. We can use our cardinal directions, east, west, or we can use relative directions, such as up and down. Displacement is defined as a change in position. Now, again, that can be a vertical change in position, denoted with a delta Y, or a horizontal change in position denoted with a delta X. Now that Greek symbol delta refers to a change in. And recall from your studies of chemistry, when we're calculating change in, we will take the final values and subtract the initial values. So we have here that the displacement is equal to the change in position, and the change in position is equal to the final position minus the initial position. Now, this term here, this subscript of 0, is not. It's pronounced X naught, N-A-U-G-H-T. And it is the same thing as saying the initial position. So X naught is often interchangeably expressed as an X subscript lowercase I. They mean the same thing. I'll typically use the symbol not because that's what appears on College Board's equation sheet. However, they mean the same thing. And the fact that in this example I'm using the variable of an X means that I'm describing the change in position horizontally for an object. Let's compare that to distance, which is a scalar quantity, which does not include direction. It's the total path an object traverses or moves. And that'll become very clear if we look at an example. Let's look at a deer that moves 10 meters to the east to a patch of clover. It then goes an additional 15 meters east to a creek, finally turning and running west 15 meters. Find the displacement. Let's represent this vectorially. Another concept discussed in Unit Not. Let's use tip-to-tail vector addition and align these two vectors, and it becomes apparent that as of this moment, the deer's total change in position is positive 25 meters. However, it turns and moves back west 15 meters. So if we align these vectors and we define our initial horizontal position, or X naught, as here, where I've put the red dot, then its final position would be right here at positive 10 meters, or 10 meters east of its initial position. Now let's use our equation to calculate its change in position or displacement. So again, we're going to take our final value of positive 10, subtract our initial value of 0, and we find that the displacement or change in position is equal to positive 10 meters, or 10 meters east, but you would not say positive 10 meters east. Let's compare that to the deer's distance. How far has it actually traveled? Well, in this case, we're going to take the scalar quantities and simply add them up, and we get a total distance of 40 meters. Compare and contrast the value we got for displacement and the value we got for distance. Displacement, signage is included to denote the direction. 10 meters is the magnitude of the displacement, and its direction is positive direction or east. Whereas with distance, we simply get our scalar value of 40 meters, and that is the total distance the deer traveled. Now let's look at our second vector quantity of velocity. Velocity is the rate of change of position with time. Rate of change, I'm going to underline rate and change of position and time, because by definition, a rate is expressed as a ratio with time. And change in position sounds familiar. That's displacement. So we can look at our equation for velocity. And I will, in a moment, distinguish between average velocity and instantaneous velocity. This equation here will give you the average velocity. And it is the change in position over the change in time, that ratio. Recall that change in position is synonymous with displacement. So displacement over time will give you the average velocity. Speed is a scalar quantity. It's the rate of change of distance with time. These are not the same. Speed does not include direction, only magnitude. And I want to elucidate this by using our previous example, but adding 2 more sentences to this problem. Now, the entire motion lasts 380 seconds. We're given the time for the entire motion, and we are asked to find the average speed and the average velocity of the deer. Think about this for a moment. The deer is walking at one point, it stops, it walks again, then it stops, it turns, it runs. At any given instant, this deer could have any given value for either speed or velocity. But we are given the time for the entire event, which means this computation will give us an average value. Let's start with speed. So we have distance over time, that rate, and we calculated previously that the distance the deer traveled was 40 meters. And we're given the time that it took as 380 seconds, which means the deer's average speed is 0.1 meter per second with one significant figure. Now, let's compare that to the deer's average velocity, which we also calculated in the previous example, which is a change in position over a change in time. We know it's change in position or displacement. We know the amount of time it took. We can finally calculate this to be 0.03 meters per second to the east. Notice when describing this vector quantity, we use both magnitude and direction. The magnitude being 0.03, direction being east. You could have also said positive 0.03 meters per second. Now, I want to distinguish the term average velocity and speed with instantaneous velocity and speed. Instantaneous is referring to the velocity or speed of that object at a given moment or instant in time. So let's say I'm driving down the road, I'm going 35 miles an hour, and then I stop, and then I accelerate, and I'm going 50 miles per hour. And my friend says, "Hey, how fast are you going?" I look down, and at that instant, my speedometer says 48 miles per hour. That's my speed at that moment. Okay, so we've been calculating average speed, average velocity, given a duration of the time for that motion. You can calculate instantaneous values using kinematic equations, which I'll teach you about in upcoming videos, calculus, which is not utilized in AP Physics 1, and motion time graphs, which we will be discussing in this course extensively. So there's a number of ways to determine instantaneous values. However, the previous examples, we calculated the average values for both speed and velocity. Our final vector quantity is acceleration, and it is the rate of change of velocity with time. Again, it's a rate. We see the word change, which means delta V, change in velocity, V final minus V initial. And the average velocity is this change in velocity. And again, we're going to take our final values minus our initial values. This V with a subscript of 0 is pronounced V naught. It is the same thing as saying its initial velocity, and oftentimes is denoted with a V subscript lowercase I. I also would like to look at the units here. Units for meters per, or for velocity would be meters per second, and we're dividing by seconds. So that means we have meters per second multiplied by the inverse of a second, which gives us the base SI units for acceleration to be meters per second, or meters per second squared. Now in AP Physics 1, we're dealing only with uniformly accelerated motion, which is often described with an acronym of UAM, uniformly accelerated motion, which means we're dealing with constant motion. Now, in this video, I'll begin to cover College Board topic 1.1, which is dealing with looking at position, displacement, distance, velocity, speed, and acceleration. And hopefully you've learned that these are a rate of change in time for both velocity and acceleration. And I'll see you guys in class.